Hi everybody, I'm Ron Williams, CEO and founder of Kindo. Today I wanted to talk about some random thoughts I've had about AI in the enterprise. I've given this talk a few times in public at a few different conferences and thought we'd get it out on YouTube to help everybody understand a little bit more about how we're thinking about the market and where things are heading. My intent's not to sell you on Kindo. It's really just to share some of these same kind of thoughts that are kind of driving how we're seeing the future develop and where we need to take our roadmap and how we think we can help customers best. So hopefully you'll enjoy it. So, on our, the first random thought I have is enough people aren't thinking about where the model is running, right? And so today, most people know about OpenAI and their model that a lot of people call ChatGPT, and maybe some of the other models that OpenAI offers. Maybe some people know about Anthropic, another popular startup that came out of OpenAI. But there's actually a lot more out there. And when you start sending your data to these AIs, you need to think a lot about who's behind that model, what they're really doing with your data, and how much you're actually trusting with these companies. And so a lot of companies will say, these third-party AI cloud providers will say, hey, we don't train on your data, or we promise we won't train on your data. Like in their contract with an enterprise, they may have a clause that says we don't train on your data. You need to dive in more, because we don't train on your data can mean lots of things. And so, for example, here's a report from Anthropic that they released earlier in the year, where they're not training on your data, but they're publishing how you use your data, how much money you're making from your data, how much money the industry as a whole is making on your data, how your employees are leveraging AI to make your business better and healthier. So net, these AI labs, like all of Silicon Valley, use data for all kinds of things. And when you're sending it out to them, you should think quite a bit about what might happen to that data in the future. Here's another great example. Again, this is Anthropic CEO. He's at a forum in Europe talking about various things about their business, but he gets on to this little story about how they're worried about China hacking Anthropic and taking their most sensitive data, which are their model weights. That's the after product of all the training that makes the model, kind of the brain inside the model. He's like, hey, we have hundreds of millions of dollars invested in this thing, and it's a fairly small amount of code. And state actors like China could take it. They may already have taken it. Like, that's his quote. What he's not mentioning, of course, they may have also already taken all the data you shared with them as well, right? So these AI labs, they're academic. They're not, the founders are brilliant people. They're hardworking, but they're not security experts. You need to kind of dive in and look at that. Like, you can go on LinkedIn and see who's running securities at these companies, and it should give you pause sometimes when you think about, sending my most sensitive secrets out of my company to these Silicon Valley AI labs. And then, another great example is OpenAI has been sued by the New York Times, some other news organizations and publishers about using their data to train their model. So there's these multiple copyright lawsuits going on, and it's unclear who may or may not win those copyright lawsuits. But this is a great example of a court order recently handed to OpenAI, just even a few weeks ago, that's requiring them now to stop deleting customer data, to prepare the data for the court and the plaintiffs of the court, so the New York Times, to review what your employees have been sending to OpenAI, what you as an individual has been sending to OpenAI. Anthropic's in similar lawsuits now with Reddit, and we can expect more of these kind of things. And so, again, as an enterprise, when you're thinking about your risk, when you send all this valuable data, how you're using the data, how you plan on leveraging AI to make more money for your business or defeat a competitor, when you're choosing these third-party AI labs, you're exposing that data to all the future lawsuits and all the future regulatory burden that's coming against AI that's still all new and nascent. And so it's another just really important thing to be thinking about. And then last, here's another report that came out, again, kind of diving in from Anthropic about how, the economic benefits of AI, like how are people actually leveraging this stuff to make money. So, even if these AI labs themselves don't want to compete with you, they're telling everybody else how to compete with you because they need growth and revenue and more people using this stuff. So, again, these are real risks. And unlike the SaaS era, when you only had to worry about maybe Salesforce losing your data to hackers, these AI companies use this data for all kinds of economic purposes. And it's really, really important to have this top of mind. Kind of last example here, it's not just the AI labs though. This is a tweet from one of Stripe's executives, the big payment company. They're out hiring an intern right now or a junior researchers to come in, analyze all of Stripe's data with AI and figure out like all kinds of cool insights about how you doing business with Stripe might help them win business with some of their other customers or maybe compete with you one day. So again, this is a new thing, new set of risks coming from AI, and I don't think enough people are thinking about it. Now, the next thing I like to think about is, and this is relevant to the first one, is, ChatGPT is not the only thing out there anymore, right? Because, and in my prior point, you might be going, well, Ron, what am I supposed to do, right? And so the fact is there's tons of AI models you can choose from the labs that we all know about, OpenAI, Anthropic, Google, Microsoft. Those guys all have models. Microsoft tends to resell OpenAI's models. But there's a ton of models out in the open source world as well. So Meta has released models that are free to use. You just have to run them on your own hardware. There's some amazing Chinese models out as well that you can trust anybody to run, but you can also run them yourself. And that's way easier now than it used to be. And so let's look at some of those things. And this is an interesting chart. It gets updated from time to time. The industry is moving so fast, but this is back in at the end of January. And here you can see that actually the leader in the best AIs for price performance, and sometimes even just the best AI, is actually Google. It's not OpenAI. And Google, even if we updated this chart today, it would look pretty much the same way. And I got another example I'll show you in a minute. But Google is actually the company that has finally woken up to the threat of AI and is now building some really incredible models at really good value. Sometimes the same performance that OpenAI gives you in a model, but maybe 10 times cheaper sometimes. And so, but they're not alone either. Like, as we can see, these lines here, which is called the Pareto frontier of price performance, it changes almost every month or every few months to different vendors. And so you don't want to get locked into a particular vendor right now. There's so much change going on, so much investment happening that you want to be open to more than just OpenAI, right? And think hard about open source models. Here's an update of April 2025, so just a few months ago now, a couple months ago, of the same thing. And again, we can clearly see here that the leader, both in performance, like highest quality responses, as well as cost performance, Google owns the entire map of that right now. Though you can also see when you dive in here, there's some great open source choices that are very performant, very high quality responses and answers, much cheaper for you to run, small enough to run yourself, and never even have to share your data with anybody else. The third key thing is a lot of enterprises are worried about hallucinations, like are these things lying to me, or are they making stuff up or whatever. That's still a problem. It's a base problem in how large language models work, but it's getting a lot better. And again, OpenAI is no longer the best one at that, right? So here's a chart from back at the middle of February, and there'll probably be an update on it soon. But again, Google is actually leading on the hallucination rate. So it used to be, if we jump back a year from now, a lot of top models were probably hallucinating 1 out of 20 times. So about 5% of the time, a model would just tell you something that wasn't exactly true. Sometimes it was a small little white lie. Sometimes it was a big crazy thing would come out. We are now seeing that falling to below 1% rate. So this is probably on par with Bob down the hall, who hallucinates sometimes at your office also, right? And so, and that's the way to think about these models. Like, are they as good as my average human in my company? If they are, don't worry about hallucinations so much. Like, it's a built-in feature of both humanity and these models, and it's gotten really good. And again, OpenAI is not the winner in this race. In fact, OpenAI's newest models, their O3 really powerful model, has actually gotten worse at hallucinations. So if you're worried about these key things, be open-minded on which model company. Think hard about open source. A lot of the models on this chart that are above other of the big labs are open source models. And if you note, Anthropic's models aren't in this chart at all. And so the next kind of big thought is, AI infrastructure spend is to the moon. Like, things are scaling crazy on the infrastructure side. Haven't seen anything like this in my career. Someone who's literally bought over probably $1 billion worth of infrastructure in my career. The numbers are pretty astounding, and the implications of that we'll talk about in a second. But here's a chart: capital spending quarterly, right? So this is a key part of these bars on this chart are quarterly spends. They're approaching $75 billion a quarter now, just from the few hyperscalers. So Google, Microsoft, Amazon, and Meta. And most of this is going to GPUs and the data centers to house these GPUs. A key player in here that's not on this chart now is X. Elon Musk's Twitter takeover has also now spending many billions of dollars as well. And the next iteration of this chart, you'd probably see them on it. But the net of this means is all of these GPUs getting bought mean that these hyperscalers are still making better models, making bigger models, more powerful models. And so none of this is slowing down. Like at the end of the year, at the end of 2024, a lot of pundits were like, oh, maybe AI's hit its peak and the bubble's going to pop or whatever. All the data shows both the models are getting way better, the models are getting bigger, but the capital spend, like, just follow the money, and you're going to quickly realize none of this is slowing down anytime soon. And then, of course, a key indicator of this, or a key implication of all this spend is, what are you going to do with all these GPUs that are coming online? And this is there's a key point that I think a lot of people are missing right now is we are actually entering a new era of computing. So we're not just getting a new piece of software in AI, but the underlying infrastructure platform is switching from CPUs to GPUs, right? And so we are now spending way more on GPUs than we're spending on CPUs. Very soon, we may cross a line, maybe just in a year or two. We may have spent more on GPUs than we've ever spent on CPUs, right? Like, there's a giant shift underway. And I've got a little data to kind of share that a different firm had put together back at the end of last year. But this is a look of 128 years of Moore's Law. So the progression, Moore's Law is, about every 18 to 24 months, the number of transistors you can fit on a chip doubles, right? And also usually it falls in cost as well, so the price performance improves along the way. The blue dots on this chart start on the left-hand side, start all the way back at the year 1897 when Charles Babbage created the first computing engine, so a little bit before chips. And then it goes all the way to the upper right-hand part of the chart where we start shifting into GPUs. So the green and yellow dots and the kind of orange shaded dots are points achieved by GPUs. And then the chart itself on the y-axis, it's logarithmic. So every one of those notches, it's improving 10x, right? So we're seeing exponential scaling on this chart, and that's measuring how many operations per second you're getting per dollar out of this particular compute. And then the x-axis is just years. So when did this type of compute get released? So Charles Babbage in 1897, he's kind of at the very bottom there, not very much compute for pretty expensive dollars. And then as we climb and we really get into the 60s on the chart is where things start getting interesting, because this is the era of the mainframe and mini computers. Most people watching this probably weren't around when these things were in businesses, but at the time, these were the dominant things in compute, and businesses were spending tens of millions, hundreds of millions, billions of dollars in today's dollars on mainframes and transforming whole enterprises and how we work as we moved off of handwritten accounting and notebooks into actual computing. It's a very important time, and we can see that we're starting to get a pretty good number of operations per second. For dollars, but this is a 20-year period, and it ends around 1980-85 when we end up with the Intel CPU finally getting into the IBM PC and the Apple II computer. and the PC era kicks off. So the mainframe era starts to die, and eventually they're pretty much all gone. There's a few still running around in certain types of businesses, but everybody today, we're running on what's, the Intel CPU architecture or competitors of it, and everything has transformed through it. And so we zoom in a little quicker or a little deeper into this as we get into the late 80s going to the 90s. The improvement over just the mainframe era, so just the 20 years when the mainframe was really dominant, moving into Intel CPUs, the cost per dollar per operation per second has improved 100,000 times. It's a massive improvement, and that was enough improvement to convince businesses, get rid of the mainframe, get rid of floors of typists, put PCs on everybody's desk, get rid of the mail room because we have email now, get rid of rewrite my whole business processes, throw away all of my software, massively transform everything. New business models came out of this, whole new types of businesses came out of it. The internet came out, all this stuff comes out of it because at the root of it, we'd improved computing by 100,000 times the cost of computing just in that 20 years, right? And so, but if we go further now, and we're getting closer to now here in the 2020s, we see in the last 15 years or so, GPUs start to come into play at scale. And GPUs have shown massive improvements, continued logarithmic scaling of how many transistors you can get on a chip, and then that dollar per operation cost continues to fall. And so over the last 20 years, now, here in 2022, 2024 timeframes, when GPUs have now entered this AI era with us, we've seen 1 billion times improvement just in the last 20 years of dollars, per operation per second. So remember, in the 80s and 90s, we threw everything away and rebooted everything for 100,000 times improvement. We're now seeing 1 billion times improvement over the last 20 years, and most businesses haven't even started on AI yet. Like this is probably the most important thing to take from the talk is how far behind everybody is. Like most businesses are running on Intel CPUs, your cloud at Amazon, your cloud at Microsoft, your cloud at Google, whatever. Those are still Intel CPUs. They're the old school PCs that have been shifted into servers running it in the cloud now. And you're running on technology that is 15 to 20 years outdated on a cost performance basis now. And so to leverage that new performance capability, you have to move to GPU infrastructure. And the way you use GPU infrastructure is with generative AI. And so the net message is we're pretty much all stuck in the mainframe of our lifetime right now. Like that's where we are. And now you can imagine, let's leap forward another 5-10 years from today. And everything we're doing today in compute is going to look like the way you feel when I say mainframe, right? That's how you're going to feel in 5 or 10 years. And so get moving on understanding this stuff. Get moving on figuring out how to get this into your organization and leverage these new efficiencies. One last kind of thought in this area too is these are now coming into workstations as well. So in the Unix era in the 90s and 2000s, you had these $20,000 desktop computers you can buy. They weren't really called PCs; they called them workstations because they were more expensive. You could charge more if you called it a workstation. Those workstations are now back, and they'll be shipping at the end of the year. So Nvidia has demoed these. Dell's building them. HP's building them. Acer is building them. Lenovo's building them. And what's interesting about this, if you look closely at this PC, this was exhibited at Nvidia's latest conference back in March. The core biggest chip on there that's on the motherboard itself, that's normally where a CPU goes in a PC. That is not a CPU. That is an Nvidia Blackwell GPU. The latest GPU is the core brain of this new workstation. It actually has another GPU in it for displaying video and playing games and stuff if you want to on this box. I couldn't identify where the CPU was on this motherboard. The CPU is now so small and insignificant in this PC, it doesn't really matter anymore. It's just going to be used for accessing some stuff on the hard drive or moving something across the network. Going forward, 2026, your developers, your creative people, the people that are doing the heavy lifting of technology in the company, they're going to be demanding these type of workstations so they can get access to this massive power cost operation per second improvement. At the end of the day, run generative AI natively on their desktop. And then here's just the last thought. A lot of people are like, wow, that's a lot, billion times. We must be close to being done. Well, we're not. Like Jensen Huang, the CEO of and founder of Nvidia, was on a podcast. This was back in November of last year. He was telling Bill Gurley's team, the famous VC, it's his podcast along with Brad Gessner, a famous other investor, that they, in the lab already, they have another at least billion time improvement ready to go over the next 10, 20 years. So we're still going to see a massive increase in capability of these GPUs. There's no slowdown. All right. So the next big thing is, hey, Ron, you're talking about all these operations per second, but yeah, that's because people are training these big AI models, right? And so, Elon built a giant data center because he wants to train another AI. That is not actually where all the new GPUs are going. There's still a lot being bought for the purposes of training AI models, but it's actually now starting to go with the new models to actually using them for day-to-day work, right? So the technical term on that would be called inference, but there's other terms for it too. So the really AI nerd term is test time compute, because you're testing kind of the model with a question and seeing what the answer comes back. And then the general term is inference compute. It means the same thing. And then what it really means to the layman is it's answer compute. So if I ask this thing for an answer, it's got to go do some compute to give me that answer, right? So answer compute is now becoming the dominant majority use of all these GPUs that are getting built, because more people are adopting them, but also the models themselves, the architecture has changed. So where the model needs a ton more time to get you a better answer, exponentially more time. And there's some important implications of that. So first, what we've learned now, it used to be the more GPUs you threw at a model, the smarter it is. Now we know if we also let the GPU think, we let the model think longer on the GPU, so it runs more cycles on these GPUs, it can answer better as well. And so we're seeing that roll out, right? So you can think of your company's intelligence. It used to be how many people, how many smart people, all the people in the company. If you added all that up, that's the intelligence I had in my company. What we're moving to now is that'll be part of it, but the lion's share part of the intelligence in your company is going to be how many GPUs, how much AI am I using across the company. So if I look, here's a couple of models being charted. This is around November of 2024, and I'm going to show you some updates to it. But it's showing OpenAI's best model, which is, at the time, is that dotted line across the middle of the chart. This is the performance on a high school math Olympiad test. So, most high schoolers would do very poorly on this. Most PhD mathematicians would probably struggle on this test. But it's for the brightest mathematical high school kids. They go to a little math Olympiad, and this is a benchmark. And they use this as a test to see how well the best models do. OpenAI's best model in November was right at that dotted line. The other lines are actually Chinese model called DeepSeek, which we heard a lot about in February, but back in November, they were already showing off they had a better model. Most people just kind of missed it. And so we can see DeepSeek not only exceeded in the score, but the x-axis on this is really important to understand. The y-axis is the percent it earned on the test, but the horizontal axis is how much thinking time the model took. So how many operations per second the model had to run to get to this better answer. And it's also logarithmic like the previous chart. So, every notch on this, things are increasing 10x more compute. So, in November, OpenAI's model, if it needed 100 compute cycles to get an answer, in order for DeepSeek to beat it, it had to run 100,000 times more compute. So massive more compute. So these GPUs are burning more and more power, being used for way longer to just get slight improvements in answers. And that's what we're seeing now with all the models you're using. The ones that are better than the ones you were using 6 months ago, they're better in part because they were trained on more GPUs, but now one of the big impacts is they're using way more of that GPU time and compute to just get you to a better answer. And each little improvement now takes exponentially more compute. So the implications of that are as time goes on and you want a smarter model, or you want a model to answer something in the future that it can't answer today, it's going to need a lot more GPUs, right? And so we're going to be spending way more on compute going forward, and we're going to need a lot more GPUs and power to feed it. Here's just a quick update on that chart. Just 3 months later, or 2.5 months later in January, the chart was pushed even further by DeepSeek. And again, you can see a whole nother notch on the x-axis of 10 times more compute. So now almost 1 million times more compute, just to go from about 55% accurate to 65% accurate. So this is just going to keep scaling and scaling and scaling. All right. Another thought, right, is we were talking about DeepSeek there, is China has actually caught up with the U.S. labs. It's now running neck and neck. China will leapfrog a U.S. lab, and then the U.S. lab, whether it's OpenAI or Anthropic or Google, will release something and slightly leapfrog the Chinese labs. And now we're seeing this going back and forth. And it's actually been speeding up as well. And this has important implications. One, obviously, there's national security ones for maybe both countries or the world generally. But the thing you should think about from an enterprise perspective is, I now have potentially cheaper model options that I can deploy besides just the ones I'm trapped into with the US labs. Because the Chinese are releasing these models open source. So you can run these models in your own infrastructure. You're not sending the data outside of the country. The Chinese labs don't get to see your data. You can just run these things privately and get state-of-the-art models that beat US AI lab models for free. Like, you just download the model. Your only cost is just running the model on GPUs. That's not cheap, but you're paying that cost to OpenAI when you use their model, or Anthropic also. So you have real options for privacy now, thanks to the Chinese. And of course, Meta has some pretty powerful models too. We're expecting a new model from Meta anytime that, if you really want a US model running privately, you'll have a great one of those probably soon too. And the cost of this is huge. Like, these Chinese models are 20 to 30 times cheaper, right? Now, so let's forget all the national security concerns, all your privacy concerns. What really should scare you is there's 75% of the world trust China more than they trust America. So that means your European competitors, your South American competitors, they are going to be super comfortable using these Chinese models and getting 20 to 30x better cost performance out of them. So that creates a real pressure on US companies to, if you stick with the more expensive US lab models, you are setting yourself up for a lot of competitive pain. So this is the random thought. So I'll show you a little bit of the data. This chart just showing that leapfrog effect between Alibaba, which runs the Quinn series of models, and DeepSeek, which is a hedge fund out of China running their DeepSeek models against OpenAI's models, right? Who everybody typically thinks is the leading lab. And you can see the Chinese continue to pass OpenAI's best models. We're currently, if we were to update this chart today, you would see OpenAI still a little bit ahead with their latest model, but it's a very expensive model to run. You can't run it privately. You have to share all your data with OpenAI. But the latest Chinese Quinn model is just slightly below it. So the Chinese are doing a great job of going neck and neck. And if you look at these two lines, how they're converging, it looks pretty clearly, if things don't dramatically change, the Chinese will eventually cross over and be above OpenAI's line and maybe hold the lead forever. So just a random thought to think about. All right. On another one is, let's talk about agents, because agents are all the rage this year. We've heard a ton about them, and it's kind of worth diving into them. In particular, it ties in nicely to the last point of why it's going to be probably important, besides competitive reasons, to have a model that's 20 or 30 times cheaper than a model today, right? And so, first of all, just another data. This is the end of Q3, as the chart came out in Q4 of 24. At that point, over $1.5 billion have been poured in by VCs into AI agent startups over the last few years. We've seen probably, I bet at least that much has gone in since this time this charts came out. But it's a lot of money, and that's why, if you're a CIO or CSO, you're probably seeing, a dozen startups a week reach out to you over email saying, I've got an agent that can help you with HR. I've got an agent that can help you with your security problems. I've got an agent that can help finance do whatever. It's because of this huge funding coming out. And so, but the stuff is real and it's important, right? So the here again is that same podcast with Nvidia CEO, And he's explaining to these guys at Nvidia, this is back in November, he thinks they'll have over 100 million agents running soon, right? And so, these agents are these little AI helpers, little bots running. Maybe they're doing very small tasks. Maybe he has an agent that just watches how many times the front door opens and closes, and then maybe he has one on a camera watching to see who's coming in. Maybe he has one on the printer, seeing what's printed and maybe report, whatever. So, but 100 million agents is a lot of agents. And if you're paying 20 to 30 times more for that GPU compute or for that model compute, that's going to add up, right? And so you really want to think about this stuff. And Nvidia, of course, that guy sells a lot of GPUs, so maybe he's overselling you, who knows? But let's see what Zuck has to say, right? So here's Zuck on a TikTok back in December, and he's like, hey, we foresee a world where we're going to be shipping hundreds of millions of billions of different agents, right? So Meta, even internally into their product, as well as what they're going to see consumers running, billions and billions of these agents coming out. So in your personal life, that might be an agent that's watching your email to let you know your mom, needs some help for Sunday dinner or whatever. Or it might be your boss has a meeting and you might want to reschedule it, or those kind of things. And so Zuck's seeing it from that world, plus everything they have going inside of Meta today. And then, at Kindo, random thought, we sell how you deploy, control AI, use it for security and DevOps purposes. And I'll talk a little bit about that related to some of these points. So one of the key things to understand is there are now AI models, open source ones, that are built specifically for hackers to use to attack enterprises, or for hackers to use to do whatever they want to do with them. They're available. There's over 1.5 million open source models today at huggingface.com. Several of them are security-oriented models built for hackers. There's all kinds of models in the dark web not released to the public. State actors are building these models. So these AI models that are being put together to come after assets, secrets, those kind of things, those are no longer science fiction. They exist in the world. We've built one at Kindo for our customers to use for red team purposes. So we understand this space pretty well, and it's something you should keep an eye on, right? Hacking is fully democratized now. And then, related to that, as the model costs have dropped, even like medium capable models. So ChatGPT, when everybody's blown away with it, that was GPT 3.5. That model is easily available in open source. You can run it on a MacBook today, open source equivalent models of that. So now combine that with hacking intelligence and capability, and you can now use that MacBook to send out 5 million highly personalized, highly targeted phishing emails for probably a few $100s in compute time or something if you did it in the cloud, if you didn't want to do it on your MacBook, right? So the scale up of this stuff is happening pretty rapidly. Google just released a report on it at the beginning of the year. We'll see more as time goes on, as AI continues to reach. And this is well beyond the deep fake issues and using, maybe tricking the finance guy with faking somebody's voice to wire money. This is now building agents to actually attack infrastructure, actually manipulate your employees in lots of different ways. So something you really want to think about. But you don't have to take it just from me. Here's Jensen again, and he's like, hey, we're to the point now where we can't run cybersecurity unless we deploy AI ourselves internally to defend. So they have agents all over their cybersecurity implementation to help defend against problems, stay on top of things. Worth thinking about. Kind of maybe a last kind of key point, and this is a new thing that's popping up. You're going to start hearing more about it, but it's really essential to get into this faster, not just because of all those other things I told you about, but also you may not get the option to in the next year or two. And this is an important thought, right? Like, everybody's used to computers getting cheaper. There's more computers next year than this year, and that is happening with GPUs. The problem is that's not happening with power. And so GPUs are huge power-hungry things. to build a power plant is not something you can just knock out in 30 days or 60 days. It's a 5, 10 year, sometimes 20-year process due to regulatory things, environmental things, they're giant complex projects, all kinds of safety issues you have to come into play. And no one foresaw all of this AI usage coming. And so no one built, there's not a bunch of spare power plants laying around, right? And so, and we're seeing rising rapid demand, exponential demand for AI usage. And right now, very few people actually are even still using AI, and we're seeing this massive demand. Once AI is in your day-to-day life at your job or at your home or at your school, the demand is going to go off the chart for GPUs, and there's not going to be any power to feed them. And so I'm going to share a little bit of that data, because we'll eventually solve that problem, but we could enter a time very soon where the only people who have access to AI are people who have bought access to it today, or own GPUs today, or maybe over the next 12 months. And then we may hit a wall where even if you want more AI, more intelligence in your business to fend off competitors or whatever, you're not going to be able to buy it at any price. Or if you do buy it, it's going to be a very expensive price, because there's not going to be enough power to power new ones until new power plants are built. And so it's just something to think about, and share you just a little bit of data on that. So one way to think about it, and Jensen talks about this in Nvidia as well, AI is now up watts of power to the number of tokens you're asking the AI to generate, right? So a token is about a word or maybe part of a word that an AI spits out. So when you're talking to ChatGPT, you're sending it tokens as part of your question, and then it sends you tokens back, right? And so in order to generate the processes of tokens, at the end of the day, that translates to watts of power in a data center or on your MacBook or wherever the GPU is running to do this work, right? And so everybody who's really deep into this and really starting to scale into it, all the big hyperscalers are a great example, some politicians as well, they're really now starting to think about this not as a GPU problem, but as how many watts do I have to allocate to AI? Because I also need to allocate those watts to electric cars. Robots are coming. Those things run on batteries. They don't run on gasoline engines. And we're going to see massive numbers of robots soon. Your house needs power. We still need factories. Most major cities, in especially times of heat wave, they can't deliver enough power today. New York just had brownouts this week with the heat wave coming in, right? And so that's before all this new AI stuff lands, right? And so these are real issues to think through. Here's Jensen just talking again back in this March, showing his roadmap of new chips. And it's interesting because all the current AI you're using, especially a couple months ago, this is just now starting to change. But if you jump back 2 or 3 months ago, every time you were using ChatGPT or whatever, you were using it on the line on the lower left-hand side of this chart. These were the Hopper GPUs, the H100s and H200s that Nvidia was selling. And now these new Blackwell GPUs are starting to hit the market and become available. It's a massive leap forward. So this is how many tokens per second that a watt of energy can generate, right? And so, or a megawatt of energy can generate. And so, so we're seeing massive improvements. Like the new GPUs NVIDIAs are shipping are way more energy efficient, a huge scale up, but it's still not going to be enough, right? And so here is a chart. And there's different data out there, so it's hard to get exact things right now. But here's a chart showing of the how many utility plants we're building, what type they are, solar, gas, nuclear, whatever, for the U.S. And we added about 20 gigawatts, which is 20 billion watts of power. A megawatt of power might power something like 1,000 homes or something. So a gigawatt of power is 1,000 times that. So maybe it's 1 million homes of power is kind of the way to think about it, depending on the type of home or whatever. And so we can see here that new power is coming online and more power is planned. And so maybe about 40 gigawatts in the US is going to get installed. But that power was planned 10 years ago, right? Before they even knew about AI, before they were sure we were even going to have a lot of electric cars. Like Tesla was still, mostly a small car company that people were wondering if it was going to survive. And now we have Waymo, and now we have all these robots coming too. So none of that was planned into that 40 gigawatts of power. That 40 gigawatts was just to prevent brownouts in New York this week, and it didn't prevent them, right? And so, but let's assume you get that 40 gigawatts. If you converted, if we just took all of that and we wanted to use it for AI and nothing else, and you look at the kind of number of employees, knowledge workers that might be using AI across today's enterprises in America, so maybe there's 100 million or so of us out there, that would give us about 0.4 of a megawatt per employee that we could dedicate just to AI, right? And bear with me here because there will be a point here we're going to wrap up at the end. And then next year, they are speeding things up. We're going to try to add 65 gigawatts. So that was last year we did 40. This year, 2025, we're going to add about 65 gigawatts of power. But after that, it might be just another 50 or 60 gigawatts a year right now. The government still hasn't fully gotten out of the way to let people just let it rip and build whatever they want to build. We're starting to see some of that. Some of the regulations starting to ease. But we're going to be constrained for a while. But again, if I was able to grab all that power and use it for AI, that'd be cool. But I can't, because the reality is that power runs the air conditioner in my house, in this office. It's running the camera, watching this. It's of course people are using ChatGPT for other things. I got Roomba vacuum and more robots coming, all that stuff. So really, we're lucky if we can allocate 1/100th of that power to AI. So all the power feeding this building for the Kindo employees, I bet. I might be able to get 1/100th of that power kind of carved out, dedicated just to GPUs, so that they can use it for intelligence, for AI work, so that might work out to about 4 kilowatts per employee. So what's 4 kilowatts, Ron? Well, and maybe next year with the new power, I'll have 8 or 10 kilowatts, and it's a lot of power. It can run many homes, maybe 8, 10 homes or more, but another way to think of it is, if we go back to Ron's CPU story, it runs about a rack of Dell servers, especially a few years ago. So if I walked into a data center, one rack of Dell servers was 10, 15 kilowatts of power was needed to run that. Sounds like a lot of power. The problem is these GPUs, even though they're getting more powerful, they consume a lot of power. And so to generate these tokens. And so if I convert 4 kilowatts of power to the number of tokens that can create for me, that will let me create about 7 million tokens, right, in a day. So if I consumed all that 4 kilowatts, and at today's Blackwell, so the latest GPUs Nvidia is selling, I can get maybe 7 million tokens with the latest Chinese DeepSeek model. Well, Ron, what can you do with 7 million tokens? Well, let's talk about that, right? So your average worker, right, your average college-educated kind of worker, they probably read 200 or 300 words a minute, right? So that'd be like 200 or 300 tokens a minute is what we're probably reading. And I'm speaking probably around 150 words a minute. So I'm speaking about, maybe I'm speaking a little faster than that, but somewhere around there, I'm speaking about 150 tokens a minute. And then if I was a developer typing pretty fast, they don't type as fast as a typist typing a letter, so they're probably typing 30 words a minute, 40 words a minute. So your developers are typing 30, 40 tokens a minute, right? Now, if I have 7 million of those a day per worker, sounds like I could get a lot done. Like this whole conversation is only going to be maybe 10,000 tokens or 15,000 tokens, I bet. So that sounds like a lot for 30 minutes or whatever. Well, the problem we have is the models are exponentially scaling in how many tokens they need to get to the right answer. So if we go back to that little math test we were talking about and the exponential growth of tokens, in order to get a little better answer, I have to burn 10 times more tokens. To get an even little better answer, I got to burn 10 times more than that. And so pretty soon, I'm not just me, the human, talking at 300 tokens per second. In order to replace Ron, to have something sit here and think the way Ron's thinking and giving this talk, that thing might need billions of tokens to have a 30-minute talk, right? That's way more than the 7 million tokens that I can generate with that 4K watts of power that I was going to allocate to Ron, right? And so, to try to tie this together for you, if today we just kind of play with AI, we chat with it a little bit, it helps us with something, it knocks out a marketing piece for us, it translates something for us, it helps me cheat on my math tests, whatever. And those are all fairly small token burdens. But if you really are, full-on capitalist, like, I want to bring AI in, I want to augment every employee with AI 8 hours a day, I want to replace some employees with AI totally, I want to leverage all this new stuff, you're no longer playing with it. You're going to, and I want to use the latest, most powerful models so that they can do human-level skilled labor work. You're going to need billions of tokens per employee per day to replace them. That's way more than the 4 kilowatts of power needed per employee that we just talked about earlier. So that's the implication. Like, if we're really going to transform a business, an enterprise, the world with AI, we need massive more power to do it, right? And so, and what that translates to power stations, like, it's not 20 gigawatts we need in a year. We need 2,000 more gigawatts of power. We might need 5,000 more gigawatts of power if AI really achieves this sitting next to Ron 8 hours a day, able to step in when Ron doesn't step in. That's how far away we are from just the power needs, not any other technology need, to get to a replacement of a human doing a job 8 hours a day, right? And people are racing towards that, though, and the models are getting to where they can do that. So that potentially, I think likely, will create a shortage of access to GPUs. We may see it as early at the end of this year or 25. I think we'll really start to feel it in 26, going into 27, because even though Jensen and Nvidia produce more GPUs, and those are supply constrained too, but they're producing more, even if those get more efficient, we are not seeing the amount of power coming online. And you can't just whip together a nuclear power plant and set it next to Venice, California suddenly to power all the AI Ron's company wants to use, right? So it's a real hard physical constraint getting ready to sit on top of the industry. And again, you don't take it from me. Here's Box founder and CEO. He was talking about OpenAI and Google's latest AI model releases. Those are the two companies obviously spending the most on GPUs right now. And in this tweet, he's like, hey, these are the two biggest launches in AI history. They all happened in the last 2 months. They're already totally constrained by capacity. The models are so good, they're attracting more people to use them, but they have to kick people off the models. They have to rate limit people. They have to do all these things, not just because they don't have enough GPUs, but they can't get enough power to install more GPUs. Elon right now with his X AI models, he's running those on natural gas generators in Memphis, Tennessee. He has something like 400 natural gas generators that he just put in a big parking lot because he couldn't get the power anywhere else to run that data center, right? Most people can't get away with that, and most municipalities wouldn't allow that kind of environmental impact. So, we're really seeing this for real already. And then, kind of the other way to think about this isn't new either. We've had this problem before. So as humans, when spinning wheels came out and when looms came out, automated looms that were powered by water wheels, you could only put those where you had a river. If you weren't near a river, you weren't allowed to be in the weaving business anymore. Same thing. If you can't get access to a GPU with power, you're not going to be allowed in the AI business until you can, right? So we've seen multiple iterations through history where new tech wave creates a new power crunch. Steam engines did the same thing. Trains, kind of did the same thing. We didn't have a track. You weren't moving stuff efficiently. Planes, like all those things we're seeing. This is just another iteration of that. And I don't think people are thinking about this enough. So the last thought on this, right, is get started hooking up your AI, right? Allocate dollars to GPUs now. Sign some contracts. Get some product in. Start using this stuff, because that may be all you have access to throughout the year 27, maybe 28, until the government and other things get out of the way and we get enough power in to let people have access to more GPUs. I'll leave it there. Thanks everybody for all your time, and we'll see you at another talk.